Right, so I'm back again to do the other half of complex numbers, which is the ARGAND diagrams. These questions are taken from the back of the Pearson Edexcel textbook for Further Maths Core 1. It's a mixed exercise, but it brings in all the different things that you learn about ARGAND diagrams, and I'm going to give it a go. I'm a Year 12 student, and I'm not saying I'm going to get all of them right, but I'm going to give them a go and then see where we went wrong. If any of you want to follow along, then that'd be great. So let's start. Alright, so we're saying the point P represents a complex number Z in an ARGAND diagram. Given that Z plus 1 minus I is 1, find the Cartesian equation of the locus of P. Okay, so we know that Z can be written as a Cartesian in the Cartesian way for X plus IY. So if we sub that in, then we get X plus IY, this is in the modulus, plus 1 minus I, and that equals 1. So we'll group together the real parts, so X plus 1, right, that should be I, X plus 1, and then plus Y minus 1 I. Okay, and that equals 1. Also, just to say before, is this is a circle. That's just something you've got to know. That form means it's a circle, but we're going to prove that now. So the modulus is the same as doing a squared, the square root of a squared plus b squared. Because c squared, because what we're doing is Pythagoras. So to get rid of this mod and put it in Cartesian form, we want to square root the whole thing and then square the terms inside. So x plus 1 squared plus y minus 1 squared, and that complex I goes as equal to 1. Now we can square 1, which is 1 times 1 is just 1, so then we get x plus 1 squared plus y minus 1 squared, which is equal to 1. Now it'll be our Cartesian equation, I think. You can see that that's an equation of a circle. So yeah, that proves that this equation is equal to the equation of a circle. Alright, so B. Sketch the locus on point P on an ARGAND diagram. Again. So let's draw our axis. This is our imaginary axis. This is our real axis. So we could use this equation, I think. So we can say that the center is going to be minus 1. So minus 1, we're here, and then positive 1. So no, my bad. Minus 1 and then positive 1 should be there, because we take the negatives of these two values, and that's going to give us our center. And then it's got a radius of 1, so it's going to hit this point here, and it's going to hit this point here. So let's see how well I draw this. Not very well, I'll be something like that. Bit big up here, but the point is it's a circle with a radius of 1. And this point is minus 1, 1. Okay. Right, so our minimum value is going to be, if I change pen over here, there's going to be a line that comes from the origin, it goes out through the center. This is going to be our max, and this is going to be our minimum. So firstly, let's just find the modulus of the center. So we know the center's 1, a minus 1, 1. We don't take minuses in the modulus. because it's going to get rid of it because we're squaring. So square root of 1 squared plus 1 squared, which is equal to, I think it's root 2, is it? Square root of 2 by 1 squared plus 1 squared. Yeah, it's root 2. So to the centre it's going to be root 2, this length here. Our radius is 1, so from here to the edge of the circle is 1. So we can say that root 2 minus 1 is our minimum. I think that's right. And then our maximum should be root 2 plus 1. Right, now it says find the greatest and least possible values of z minus 1. So you can see from here to here it's like, I think it's it would be a transformation. Let's draw this new graph. So this new graph will, sorry about that. We're gonna move it, rather than going negative 1, we're going positive 1. So the centre is going to go from minus 1, 1 to 0, 1. So we're going to go up here. This is 0, 1. And it still has a radius of 1, which means it's going to go through the origin. Okay. So now we can draw our line on. From the origin, it's just going to go straight up. Like that. Okay, so we can say, because our coordinates are 0, 1, if we have this length here is 1, then we're going to do 1 minus 1, that's going to be 0, 0. So minimum of 0, maximum of 1 plus 1, which is 2. Right, let's move on to the next one. Right, so the question says, given that arg z minus 2 plus 4i is equal to pi over 4, sketch the locus of P which represents z on an ARGAND diagram. Right, so we know that the form, we got arg z minus z2 equals theta. So because we got this minus, we need to put it in this form. So we can say that arg of z minus, and then in brackets, to get our minus, we just have 2, sorry, that should be z, minus 2, then we're going to get minus 4i equals pi over 4. So if we put this, let's say A here, on an ARGAND diagram, then our point is going to be 2 minus 4i, so 2 over here minus 4i, 2 minus 4, so that this is the real and this is the imaginary. So then we draw a line going from here, which means that our angle theta the thing that's throwing me off though is that, see, we have pi over 4. Pi over 4, because you can have negative angles in when you have an arc, pi over 4 should be up here. This would be minus pi over 4 down here. Let me just check that I've done this right. You have the minus, get 2 minus 4. It looks right. Well, I'm going to carry on. I think I've done something wrong here, but I can't see what's happened, so we're going to leave it like that, saying that I'll rub this bit out. And then we'll move on to the next one. Might have got that one wrong, I'll be honest. Find the minimum value of the modulus of z for points on this locus. Right. So we thought that the minimum point would be at the origin, I think. Because at the origin you would have the square root of 0 squared plus 0 squared, which equals 0. I'm going to say that the minimum is 0. We're going to have to go back and look at that question, the mark scheme at the end, but if you guys got that, then word up. Right, so the question says the complex number z satisfies this. Well, we know this is a circle. It's the first bit of information. And it's got a radius of 3. Show the exact maximum value of argz in the interval of this. That looks pretty scary, but I'm sure we'll be able to deal with it. So we got to get this in the form of our circle. So it's the modulus of z minus 3 plus 6i equals 3. So if I come over here and draw a diagram, then we can come over here and say that the centre is going to be minus 3, 6, which is going to be here, minus 3, 6, and it's going to have a radius 3, so it's going to hit this point here. Let's try and draw that. I should be touching it there. Bit messy, but that's fine. And this has a radius of 3. So we know that the arg is the angle, and the largest angle from this axis is going to be over here. So see if we can draw that. There you go. And you might notice that that's a tangent, and there's also going to be a tangent that runs down here. So our arg of our maximum is going to be from this, the angle from this line all the way round to this line. But we already know that here it's 90 degrees basically, because our tangent is on the y-axis. So, but we're doing this in radians, so we know that our angle is pi over 2 there. So this angle here is pi over 2. So that makes part of our larger angle here. So we can note that down. So the next thing is we want to find this part of the angle. So how are we going to? Well, we have the centre, don't we? And we know that a radius meets the tangent at 90 degrees. So if I draw that to there, we know that is 90. And if I draw that to there, we know that that's 90. That looks like a terrible drawing. We can also draw a line down here, and we have two right angle triangles. So I'm going to bring that over here and say that we have this point here. We have a point coming out here, point coming out here, down to the bottom, like a kite shape, and a line there. And these are right angles. This is our minus 3, 6, and we know that these are both 3 because they're both the radius. So if we want to find these angles here, we have two right angle triangles, we need to find the modulus, and then we can do trigonometry. So the modulus is square root of 3 squared, the minus just goes because we're going to square it, so I'm not going to include it, plus 6 squared, and that equals the square root of 3 squared plus 6 squared gives us 3 root 5. So we know that this length here, or modulus, is 3 root 5. Now let's just focus on trying to get one of these angles. Let's call this angle theta. We've got the hypotenuse and we've got the opposite, so it's going to be sine. So sine theta is equal to the opposite, which is 3, divided by 3 over 5. Okay, so then you can see now, I think, we're getting close to the answer because we've got our pi over 2 plus, it's saying 2 because we're going to have 2 of these angles, arc sine 1/5. So this should equal arc sine 1/5. So how we can get that? Well, we can say that this is equal to, if we divide by 3, 1 over root 5. Now if we do arc sine of that, or sine to the minus 1, then we say theta is equal to arc sine of 1/5. Now we've got that, we know that we have another theta here. So our arg of z here is going to be the addition of our 2 thetas plus our pi over 2. So we can say that pi over 2 plus 2 arc sine 1 over root 5. And you can see that's the same as this, so it should be right. There you go. Let's move on to the next one. Right, so it says a complex number z is represented by a point P on an ARGAND diagram, given that z minus 5 equals 4. So that's a circle. Sketch a locus of P. Okay. So we've got, we know that the formula should be z minus z2 equals radius. So let's put it in that form. Z minus, and then it's going to be 5 equals 4. That's just going to show us that our centre is 5. So if we sketch that, then we have a centre of 5. That's on our real axis. So centre of 5, and then a radius of 4. So something like that. This is 5, 0. This is a radius 4. Find the complex numbers that satisfy both z minus 5 equals 4 and arg z plus 3i equals pi over 3. This is a long 6 marker, so I'm going to start this. So the complex number that will satisfy this will lie on the circumference, and we also want to find arg z plus 3. So let's do this. So arg z, and we want minus 3i equals pi over 3. So the point should be minus 3i. Minus 3i is going to be down here. I'm just thinking, if it's minus 3i, which is about here, then our angle would not be pi over 3. So we might be missing something here. Pi over 3, that's good, because that would be, our arc would be that angle, which doesn't make any sense. arg of z plus 3. No. Not sure about that. It's similar to the last one that I got stuck on, so maybe I'm missing something with these type of questions. I'm gonna have to look at marking for that. On the next slide I'll do this. I'll try and do this. Oh, I can do it here actually. So C, given that arg z plus 5 equals theta and z minus 5 equals 4 have no common solutions, find the range of possible values of theta in the range of minus pi to pi. So given that arg z plus 5 equals theta and z minus 5 equals 4 have no common solutions, find the range of possible values. Well, I'm not even sure where to start on that. Alright guys, so I just finished marking my test, and I've wanted to go through 3 questions that I got wrong. So this one here, the first 2 were fine, and then when it says find the greatest and least possible values of x, or the modulus of x, that was fine, but then when you go to, when it says z minus 1, that means that you translate, or use to translate the origin basically along and then find the modulus from there. So that's a fairly easy fix, but yeah, and then you would get the answer of root 5 plus 1 and root 5 minus 1. So if you got that, then well done. Yeah, and then we'll move on to the next one. This next one wanted, when it said sketch the locus of P, that was fine. And then when it said find the minimum value for of modulus Z for points on this locus. So a half line is going to be, it has a point, so we've got this point here. I got that fine, but I forgot that it doesn't have to always come from the origin. So the actual line, you can see it started at 4 minus 2, but it comes across and touches the real axis, which means that the arg will be a quarter pi. So and then the Cartesian one was working off of that and then just subbing in x plus iy. So the next one was a similar thing, was that the point on which a half line lies doesn't have to go through the origin. So it's obviously something I need to work on, but you can see down here that the half line starts here, which I plotted, but it doesn't have to go through the origin, so I actually went through this line, and then from that you can work out the rest of the question. So I think the main thing to pick up on is that half lines don't have to go through the origin, and yeah, if you guys got that right, then well done, and I hope you enjoyed this video, and hopefully I'll be making some more math videos, maybe some physics videos, and doing some more engineering on small engines. So hope you guys enjoy it. Thanks.